Hello, this is a short video presentation, hopefully short, on graphing radical functions part 2. First of all, I want to revisit the last video, and I want to look at some generalizations that you should have noticed after graphing a few functions. One, if the radical is positive, the graph goes up. Notice this went up. This one went up. This is negative, and the graph went down. You should have noticed that as you were graphing today or yesterday. And lastly, if the x is positive, the graph goes to the right. If the x is negative, the graph goes to the left. Here it's positive, it went to the right. All right? It's always going to be that way. The other thing you should have noticed is that from the starting point, we went over 1, up 1, always, or down, depending. The square root of 1 is 1. Over 4, the square root of 4 is 2. Over 9, the square root of 9 is 3. And any guesses? Yep, if I go over 16, the square root of 16 is 4. It's always like that, all right? Just like graphing quadratics. Quadratics, we went over 1, 1 squared is 1. Over 2, 2 squared is 4. It's exactly the same idea, except we're switching the x and the y. All right, now we're going to put a number in front of the radical. So let's come up with some equations. All right, the first graph I want to look at is 3 plus 2 times the square root of x plus 4. As before, we take the x plus 4, set it equal to 0, and we get negative 4. My starting point then is negative 4, 1, 2, 3. Now, if x is negative 4 plus 4 is 0, 0, square root of 0 is 0, times 2 is 0, and then 0 plus 3. I'm not even sure what happened there. And negative 4 plus 4. Y is going to turn out to be 3. So, the x is positive, I go to the right. This is positive, I go up. But now, instead of going up 1, over 1, up 1, 1 times 2 is 2, I go over 1, up 2. Instead of going over 4 and up 2, 2 times 2 is 4, 2, 3, 4. And again, I'm going up from the starting line. Instead of going over 9, up 3, 3 times 2 is 6, 5, 6, 7, 8, 9, 1, 2, 3, 4, 5, 6. So my graph is steeper. And it continues to go up. It does not go straight. All right, let's look at a different one. Y equals negative 2 minus 1/2 times the square root of x minus 3. So we set the radicand equal to 0. So x is 3 and y is negative 2. 1, 2, 3, 1, 2. And then because this is negative, I go down. Instead of going, and x is positive, I go to the right. Instead of going down over 1 and down 1, I go down a half. Instead of going over 2, 3, 4, down 2, I go down 1. And instead of going over 9, 5, 6, 7, 8, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, and down 3, 3 times a half is 1.5. And again, it's always off of this line here. So my graph looks like that. All right, I'm going to do one more. Y equals 1 minus 2 times the square root of 5 minus x. All right, because this is negative, I go down. Because x is negative, I go to the left. I start at 5, 1, 2, 3, 4, 5, and up 1. And now I go over 1. 1 times 2 is 2, I go down 2. I go over 2, 3, 4. 4 square root of 4 is 2. 2 times 2 is 4. And then 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6. And then I should be able to do 16. So this was 9, 10, 11, 12, 13, 14, 15, 16. Square root of 16 is 4. 4 times 2 is 8. 1, 2, 3, 4, 5, 6, 7, 8. And my graph looks like this. And there we go. That's all there is to it. All right. Hope this makes sense to you. Graphing these should be very, very simple. All right. Talk to you later. Bye.